OSI model, or Open Systems Interconnection Model, is like a universal language for computer networking. Developed in 1984 by the International Organization for Standardization, it breaks down the complex process of network communication into 7 distinct layers. Each layer has a specific job, and they all work together seamlessly to move data across networks. Think of it as a team of specialists, each with their own crucial role in getting your data from point A to point B. It's like the ultimate blueprint of how data zips across the digital universe. Understanding the OSI model is like gaining a superpower in the world of networking. It helps you grasp how networks function at a fundamental level. This knowledge is invaluable for troubleshooting network issues. You'll know exactly where to look when problems arise. For those eyeing a career in IT or networking, the OSI model is essential knowledge. It's the foundation that much of networking is built upon. Plus, it makes those complex network concepts much easier to understand. It's the common language that network professionals speak worldwide. Whether you're aiming for IT stardom, or just want to be the hero who fixes the Wi-Fi at family gatherings, the OSI model is your ticket to digital mastery. Let's take a quick tour of our 7 layers. Starting from the bottom, we have the physical layer, which deals with the actual hardware. Next is the data link layer, ensuring reliable data transfer between directly connected nodes. Then comes the network layer, which handles routing between different networks. Above that is the transport layer, managing end-to-end communication. The 5th layer is the session layer, which establishes and maintains sessions between applications. Second from the top is the presentation layer, formatting and encrypting data. And finally, we have the application layer, which provides network services to end-user applications. Each layer builds on the services of the layer below it, working together to make our digital communications possible. Together, they ensure your latest tweet, cat video, or top-secret email reaches its destination. Remembering these layers in order can be tricky, so let's learn some memory tricks. Here's a popular mnemonic: please do not throw sausage pizza away. Each word represents a layer from bottom to top: physical, data link; network, transport; session, presentation, application. If you prefer top to bottom, try all people seem to need data processing. Pick whichever works best for you. These mnemonics might be weird and wacky, but that's exactly why they work. Another helpful approach is to group the layers conceptually. The bottom 3 layers are the media layers, focusing on data movement. The top 3 layers are the host layers, dealing with data processing. The transport layer in the middle connects these 2 groups. Think of it as a towering layer cake of digital deliciousness. The bottom 3 layers are like a hyperspace delivery service, while the top 3 are like universal translators in a sci-fi movie. And right in the middle, our transport layer is the jam holding it all together. The physical layer is the foundation of our networking cake. It deals with the actual physical connection between devices. Its job is to transmit raw bits, those ones and zeros, over a physical medium. This could be electrical signals through an Ethernet cable, light pulses in a fiber optic cable, or radio waves for Wi-Fi. Protocols like IEEE 802.11 for Wi-Fi and Bluetooth operate at this layer. The key concepts here are bit transmission, the physical medium, and signal encoding. It's like a digital gymnast, transforming your data into a gold medal-worthy routine of flips and twists that can traverse the globe. Moving up, we reach the data link layer. If the physical layer is about moving raw bits, the data link layer ensures those bits are transmitted reliably between 2 directly connected nodes. It's responsible for framing data into manageable chunks and uses MAC addresses for physical addressing. This layer is where your network interface card (NIC) operates, and where network switches do their work. Protocols like Ethernet and the Address Resolution Protocol (ARP) function here. The data link layer also handles error detection, making sure the data hasn't been corrupted in transit. It's like a super efficient postal service for your local network. The network layer is the Internet's traffic director. While the data link layer handles communication between directly connected devices, the network layer determines how data is sent between devices on different networks. This is where IP addresses come into play. The network layer figures out the best path for your data to travel, even if it has to hop across multiple networks. Routers operate at this layer, using protocols like IP, Internet Protocol, and ICMP, Internet Control Message Protocol. Key concepts here include logical addressing, routing, and packet forwarding. Thanks to this layer, your online gaming session can connect you with players from Tokyo to Toronto faster than you can say lag. The transport layer acts as our network's delivery service. It ensures complete data transfer and handles the nitty-gritty of breaking data into segments and putting it back together. This layer introduces the concept of ports, allowing multiple applications on a device to communicate simultaneously. The two main protocols here are TCP, Transmission Control Protocol, and UDP, User Datagram Protocol. TCP is like sending a package with a signature required. It's reliable but a bit slower. UDP is more like regular mail, faster, but with fewer guarantees. This layer also manages flow control and error checking. As we move higher, we reach the session layer. This layer is responsible for establishing, managing, and terminating sessions between applications. Think of it as a facilitator for conversations between applications. It sets up the communication channel, keeps it active for as long as needed, and then closes it down when the job is done. This is where things like API calls and authentication often happen. Protocols like NetBIOS and SIP, Session Initiation Protocol, operate at this layer. While it's not always the most visible layer, it's crucial for keeping our digital conversations flowing smoothly. The presentation layer is our data translator and formatter. Its main job is to make sure that the data from the application layer of one system is readable by the application layer of another system. This involves three main tasks: translation, encryption, and compression. It might need to translate between different data formats, encrypt data to keep it secure, or compress it to make it travel faster. Protocols like SSL, Secure Sockets Layer, and TLS, Transport Layer Security, work here, as well as data formats like JPEG and GIF. This layer ensures that regardless of differences between devices, the data remains usable. Finally, we reach the application layer, the one we interact with most directly. This layer provides network services directly to end-user applications. Your web browser, email client, and other internet-connected applications work at this layer. It's responsible for identifying communication partners, determining resource availability, and synchronizing communication. Protocols like HTTP, FTP, and SMTP operate here. The application layer is where the user interacts with the network, making it the most visible part of our networking stack. It's the icing on our layer cake, the cherry on top of our networking sundae. Now that we understand each layer, let's see how they all work together when you access a website. You type a URL into your browser. That's the application layer in action. The presentation layer formats your request and may encrypt it if it's a secure site. The session layer establishes a session with the web server. The transport layer breaks your request into manageable packets. The network layer determines the best route for these packets to reach the server. The data link layer gets your data onto your local network. Finally, the physical layer converts your data into signals and sends them out. This whole process happens in reverse on the server side, and while you're browsing the web. Let's tell a quick story about how data travels through these layers. Imagine you're sending an email. Your message starts at the application layer where your email client creates it. It then passes through the presentation layer, which might encrypt it for security. The session layer sets up a communication session, and the transport layer breaks your email into packets. The network layer figures out how to route these packets to your recipient, while the data link layer handles the transfer to your local network devices. Finally, the physical layer converts it all into signals that can be transmitted. This journey happens incredibly fast, and a similar process occurs in reverse when your recipient gets the email. Understanding the OSI model can be incredibly helpful when troubleshooting network issues. No internet connection at all? That's likely a physical layer problem. Check your cables or Wi-Fi signal. Website not loading? Could be a network layer issue with routing. Downloads keep getting corrupted? The transport layer might be dropping packets. Can't log into a website? That might be an application layer problem. By knowing which layer is responsible for what, you can pinpoint problems more quickly and know where to start fixing them. With the OSI model as your guide, you'll be solving digital whodunits in no time. Time for a quick quiz. This section will describe some everyday tech scenarios, and it's up to you to guess which OSI layer is the star of the show. Ready? Here we go. First scenario, credit card details turn into secret code when shopping online. Second scenario, a video call to grandma takes the fastest route across the country. Third scenario, that massive game download arrives on the computer without a single missing piece. Fourth scenario, a laptop connects to the coffee shop Wi-Fi. Fifth scenario, opening up a favorite social media app. Think about each scenario. Which layer is doing the heavy lifting? Don't worry if it's not immediately clear. This is all about learning and having fun. Take a moment to consider each scenario and make a guess. Once all the guesses are ready, it's time to check the answers. Now let's review the correct answers. For the first scenario, encrypting credit card details is the presentation layer at work. For the second scenario, finding the quickest path for the video call is thanks to the network layer. For the third scenario, making sure the game download is complete is the transport layer's job. For the fourth scenario, connecting to Wi-Fi is the physical layer in action. And for the fifth scenario, opening the social media app is the application layer, of course. How many were guessed correctly? Even if not all were correct, thinking about networks in terms of these layers is already a step towards becoming a network pro. Each of these everyday tech moments is like a mini adventure through the OSI layers. It's fascinating to realize how these layers work together in our daily digital interactions. The OSI model's 7 layers: physical, data link, network, transport, session, presentation, and application form the backbone of network communication. This framework helps us understand how data travels across networks, from physical signals to the apps we use daily. While modern networks don't strictly adhere to the OSI model, it remains an essential tool for network professionals and enthusiasts alike, offering valuable insights into the complexities of digital communication. As we conclude, remember that every online interaction involves these layers working seamlessly together. We hope this exploration of the digital world that connects us all has been insightful and engaging. We would love if you subscribe to stay updated on more tech breakdowns and insights. Thank you for joining us on this journey through the OSI model. Keep learning and keep connecting.